This video is for educational purposes only. Always perform experiments under adult supervision and follow safety guidelines. Before we dive into our exciting experiments, it's crucial to remember that safety is our #1 priority. Just like a superhero never goes on a mission without their gadgets, you should never start an experiment without your safety gear. So grab those goggles, put on those gloves, and make sure you have an adult nearby to help. Ready? Let's make science our superpower. Welcome to Arif Science. Lab. Hey everyone, welcome back to the channel. Today, we're diving into the world of science with some mind-blowing experiments you can try at home. I've always been fascinated by science. It's how I learned to explore the world around me. But you don't need a high-tech lab to explore the wonders of science. With a few simple ingredients, you can unleash your inner scientist and create some seriously awesome reactions. Let's get started. Alright, first up, we're gonna make something called elephant toothpaste. This isn't your typical toothpaste, and it's definitely not for brushing your teeth or fangs. It's a fun and foamy chemical reaction that looks like it could clean an elephant's teeth, hence the name. Don't worry, no elephants were harmed in the making of this experiment. It's just a playful name for a really cool science demonstration. We're going to use hydrogen peroxide, which is like water, but with an extra oxygen atom. This extra oxygen makes it a powerful oxidizer. It's pretty unstable and wants to break down, which releases that extra oxygen. When it does, it creates bubbles of oxygen gas. Now, yeast is going to be our catalyst. A catalyst is something that speeds up a chemical reaction without being consumed in the process. It's like a speed demon for chemical reactions, making things happen way faster. The yeast helps break down the hydrogen peroxide quickly, so when the yeast meets the hydrogen peroxide, it's going to cause a rapid decomposition, releasing a whole bunch of oxygen gas. This gas gets trapped in the soap, creating a lot of foam, and to make it extra cool, we're going to add some dish soap to capture that gas in a mountain of foamy goodness. The soap helps to trap the oxygen bubbles, making the reaction look like a giant frothy explosion. Next, we're going to create a classic volcanic eruption right in your kitchen. We'll be using baking soda, which is a base, and vinegar, which is an acid. Now, when these two meet, they react to form carbon dioxide gas. It's the same gas we breathe out, and it's what makes soda fizzy.
We're going to build a volcano shape around our baking soda using some Play-Doh or even just dirt. Then when we add the vinegar, the gas will build up inside the volcano and boom, eruption time. It's a mini volcano without the molten lava, which is probably for the best.
Now, for a little espionage action, we're going to make some invisible ink. We'll be using lemon juice, which contains carbon compounds. When these compounds are heated, they oxidize, which means they react with oxygen in the air. This reaction causes the compounds to break down and form new substances which appear brown on the paper.
So, we can write a secret message with lemon juice and it'll be invisible until we apply some heat. A light bulb or even ironing the paper will do the trick. It's like magic, but it's science.
Chapter 4.
Have you ever wondered why some things float and others sink? It's all about density.
Density is how much mass is packed into a given volume.
An object will float if it's less dense than the liquid it's in.
An egg is slightly denser than plain water, so it sinks.
But we can change the density of the water by adding salt.
Salt makes the water denser, and when the water becomes denser than the egg, voila, the egg floats.
It's like a magic trick, but it's just science doing its thing.
Chapter 5, Homemade Lava Lamp. Groovy science, no lava required. Alright, let's create a groovy lava lamp. This is a fun and easy science experiment that you can do at home with just a few simple ingredients. We'll be using oil and water, which are immiscible, meaning they don't mix. This is because oil molecules are non-polar and water molecules are polar, so they repel each other. Oil is less dense than water, so it floats on top. This difference in density is what helps create the lava lamp effect. Then we'll add an Alka-Seltzer tablet, which contains citric acid and baking soda. When it dissolves in water, it creates a chemical reaction. Remember our volcano experiment? We used baking soda and vinegar to create an eruption. When these two ingredients react in water, they produce carbon dioxide gas. This gas forms bubbles in the liquid. The gas bubbles attach themselves to the blobs of colored water and cause them to rise to the top of the oil. This creates a fascinating visual effect. When the bubbles pop, the colored water sinks back down, creating a mesmerizing lava lamp effect. It's a simple, yet captivating way to explore the principles of density and chemical reactions. Chapter 6. Rainbow Milk. Turning milk into a work of art.
Get ready for an explosion of color with this rainbow milk experiment. We'll be using milk, which contains fat molecules, and dish soap, which is a surfactant. Surfactants break down the surface tension of liquids, which is what holds the fat molecules together in milk. When we add the dish soap to the milk with drops of food coloring, the soap molecules race around trying to attach to the fat molecules. This movement creates currents in the milk, causing the food coloring to swirl and mix, creating a mesmerizing display of color.
Chapter 7. Instant Ice. Turning water into ice before your very eyes.
For our final experiment, we're going to do some instant ice magic. This is one of the most fascinating phenomena in the world of science, and it never fails to amaze. Imagine turning liquid water into solid ice in just a blink of an eye. Sounds like magic, right? But it's all about science. We'll be using water, but we're going to supercool it. Supercooling is a process where we lower the temperature of the water below its normal freezing point, yet it remains in liquid form. This is a delicate process that requires precision and patience. Supercooling means chilling water below its freezing point without it turning into ice. This happens because the water needs a nucleation point, something to start the freezing process. Without it, the water stays liquid even at temperatures where it would normally freeze. We can do this by carefully controlling the temperature and making sure there are no impurities in the water that could trigger ice crystal formation. The water must be pure and the environment must be stable. Even the slightest impurity or disturbance can cause the water to freeze prematurely. Once the water is supercooled, any disturbance, like a tap on the bottle or adding a small ice crystal, will cause the water molecules to instantly arrange themselves into a solid structure, creating ice right before your eyes. This is because the disturbance provides the nucleation point needed for the water to start freezing. It's a stunning demonstration of the principles of physics and chemistry working together in harmony.
Thanks for watching. If you enjoyed these experiments, don't forget to like, subscribe, and hit the bell icon for more awesome science content. Remember, science is everywhere, and anyone can be a scientist with a little curiosity and a willingness to experiment. Keep exploring, keep questioning, and keep having fun with science. See you next time.